a little ahead of schedule, but I don't know. I'll run with it. Uh, okay, Nick, I guess you're up if you're ready.
Yep, I'm ready if you guys are.
Yeah, if you guys remember this from last year's Nick's gigantic 3D model thing again.
Yes, hi, I'm Nick. I am an architecture graduate. I have my degree in architecture, although currently I work doing auto shows. So if you're ever in the area where an auto show is going on, you can go and see them. We have Detroit coming up soon, and then Chicago and New York. They're really interesting. So take a look if you can. Last year I did my presentation specifically on the pros and cons of using 3D to create your environments. And in that presentation, I remember a number of people expressing an interest in learning a bit more about the architectural design process itself. So that is going to be the focus of this year's presentation. I'm going to attempt to cram 4 years of architecture into about 15 minutes. So let's see how well that goes. So the text that I'm using as the basis of this presentation is Architecture, Form, Space, and Order by Professor Francis Ching. It's available on archive.org for free, or if you want, you can go out and actually buy the textbook. It's pretty cheap for a textbook, especially if you get it used, like 15, 20 bucks, if you feel as though you want to get more interest into architectural design. So the intention of this presentation is to provide both creators and fans with a design vocabulary so that you can speak intelligently on the topic of architectural design. I think that oftentimes in the visual novel community, we get a lot of focus on characters, a lot of focus on plot, but sometimes the environments get a little forgotten about. They get sort of pushed to the side. People kind of forget about that. But if you're wanting to create a game, a story that really engages the readers, really draws them in, I feel as though having a well-designed environment is also an important aspect to that. So what I'm going to be talking about today can apply to 2D or 3D, whatever medium you're designing your environments in. This is all basic architectural concepts, so it's not medium dependent. So we'll start right at the beginning with primary elements. These are point, line, plane, and volume. So a point is just a single position in space. It's basically 0 dimensions. But even though it's just a single point, there's still can be a dynamism to it. If you notice on this top row here, we have a point that's centered in a field. It's exactly center, so it feels very static and fixed. So it has sort of a weight to it in centering it there. Whereas down in the bottom row here, I've set the point off center, and immediately just by doing that, you've added a bit of dynamism to the space. The point isn't as centered in the field. Just the act of pushing it off makes it so that the area, say, on this side of the point is different than the area on this side of the point. Then when you make that 2-dimensional, it becomes a line. A line is essentially a connection between 2 points. It's being connected between those 2 points. And not only does it define the direction from the point to the point, it also defines an axis perpendicular to those points. And so, again, if you have just a line that's like straight horizontal, straight vertical, it can feel very static and stable. But if you want to add some dynamism to it, you can put it on an angle. That just placing it obliquely adds that sort of dynamic tension to the elements. And a line doesn't have to be straight. It can also be curved. It can, change and twist throughout the environment. There can be buildings and spaces that have these linear forms rather than simply a point in space. Then when we add the next dimension, the 2-dimension, it becomes a plane. Now a plane has both length and width. It's defined by multiple lines that create it, whether it's enclosed or unenclosed. And so they have shape as well, if they're just a rectangle, a circle, a triangle. And it doesn't necessarily have to be completely enclosed as in these examples. It can also be implied. You can have a series of parallel lines that sort of imply a plane without a plane exactly being there. So an example of which is when you have a colonnade. When you have a number of columns in a row to define a space, you don't have a complete wall, but it still implies, it feels as though there is a wall there. And then once we go from plane, add the 3rd dimension, volume. Bam, we take that into 3 dimensions. So it has both a length, a width, and a depth. And in doing so, it goes from being a shape to being a form. And these forms can either be solid, as in the cube here, or they can be the space inside the solid. And that's really what architecture is. More than the form of the building, it's the spaces that the form of the building creates. The building form itself is the volume in space. Okay, so now that we have those basic elements on, we can start to talk about form. So forms have a number of visual properties. They have shape, size, color, and texture, along with a number of other properties that you can get into. So shapes and solids are essentially a visual contrast between the figure and the ground. If you've ever seen those images that show what looks like a vase or two faces, depending on what it looks like, you have essentially what is the figure and what is the ground. And depending on how you render those is what defines which as which. And these forms can be regular or they can be irregular. A regular form is, like a cube, a circle, a square, but an irregular one sort of creates a different kind of shape to it. It's not as one of those simple defined aspects there. So if we go through here, we have essentially, here's a whole bunch of different forms that are created. Whether you go from cube, pyramid, cone, spheres, those are all the regular ones. And then you can start to make them irregular by performing various transformations to it. So essentially all form is a transformation of one of those original primary solids. So you can have what is a dimensional transformation, which is taking it, squishing it, skewing it, pulling apart, but you still kind of retain that original shape. And there are also two other types of transformation. You have subtractive transformation, where you're taking the form and removing pieces of it, or you have additive, where you're taking the original form and adding things to it. So essentially, let's see. Yep. So subtractive form, what we do when we look at something that's being subtracted is our mind, the human mind, tries to look for regularity. It fills in what is missing. So when you have this cube with this corner taking out of it here, you can still recognize it originally as a cube. Though as you remove more and more pieces of it, it becomes more and more difficult to realize what that original form is. And when we get to additive transformation, we can have different types of tension depending on the relationship between these added forms. If you can have a spatial tension simply by having objects that are in proximity to each other, and then that sort of changes whether it's touching at an edge, whether it's touching at a face, or whether it's overlapping entirely. And so when we get to architecture, we have a lot of these various forms that start to interact and flow with one another in order to create the spaces that we're making. So if we look over at different ways that we can arrange these shapes, there's a number of sort of basic principles in the way in which we can organize them. We have sort of this centralized form in which the main object is centered, and then you have subordinate objects surrounding it. You can take and stretch it linearly, whether it's a repetition of elements or the transformation of an element to create the new form. We also have radial, where there's a number of objects that are kind of centered around a central point, but they have a kind of radial symmetry. They orbit around that central point, and they can sort of grow and twist from there. And then we also have a number of various ways to cluster these together, either sort of arbitrarily or on a particular type of grid that sort of defines the aspect that we're putting all of these little pieces into, a way to organize them so it doesn't necessarily just seem arbitrary. Let's see here. So that's form, and then we get up here to space. So form and space are sort of the unity of opposites. You can't have one without the other, because obviously an object needs to exist inside of a space. How else could you do it otherwise? So essentially, positive elements are perceived as the figures, and negative elements provide the background to those figures. So if we start out with horizontal planes, they're essentially laying a figure on that contrasting background. There's a perceptible change between the plane surface and the field that it exists within. So a number of options for these horizontal planes is it can simply be in ground with the field, as shown in this corner. You can sort of elevate it above the base plane, you can depress it beneath the base plane, or you can raise it up so high that it becomes a separate plane entirely, serving as sort of a roof or a ceiling. And then we move in the other direction, we have vertical planes. Now, again, you can imply the planes by simply placing a column. You can tell that there is a volumetric space inside of these elements. It's not literally called out, but it's implied by there. You can understand that the space in here is separate from the space out here simply by the placing of those elements. And then we start to add dimensions to it. We have a single line, a single vertical element, which is basically a wall. We have two of them coming together, which can either be, together at a corner, you can tell that there's a space in here. Having two parallel lines, you can tell there's a space in here. And then we just keep adding and adding. See, you can still imply the space in there, even though it's not called out specifically, until you get to here. And then you have all four directions are defining that space. And then you have your space, but what about it then? Well, then we start putting openings in it, doors and windows and such, because otherwise it's just, this empty space. So essentially a door is, it's an actual physical connection between the inside space and the outside space, whereas a window implies a visual connection. You can't physically pass through it, but there's still a connection between inside and outside. It sort of erodes the edges of the planes the more holes that you start to puncture into it. And you can place these, they can be placed just in the plane. They can be repeated. You can get them sort of towards edges and corners and stuff. And each one of those is going to give you a different feeling of that space, whether you have, clear stories or skylights and different sort of things. Just depending on where you're puncturing those openings is going to change the character of the space that's inside there. Okay, so now we get up here to organization and relationships. So we have just one space, but very few architectural spaces are just a single space. It's a whole bunch of spaces all related together in some fashion. So the simplest one is just a space within a space. You have the outer space here, the inner space here, some sort of vertical elements are defining the separation between those spaces, and you have the openings that connect them. You can have interlocking spaces. We have the two cubes here are coming together. You can still recognize that each one is a cube, but then they've created this third space in the middle. And you can sort of define that, just as itself. You can start to put other sub-elements inside here. Each one of these instances, it's the same two original shapes, but that shared space between them is being defined in a separate manner. And moving up here, you have you can get to adjacent spaces that are next to each other, and they can have different characters between them. They can be divided different ways, whether there's a single opening, some sort of barrier between them, an implied wall in between them, even just the changing of a plane. You see here that there's no wall here, but you can tell that these two spaces are different simply by the step up. They're defined as separate spaces just by the change in plane there. And then a few other relationships here. They can be linked by a sort of a common third space between the two original spaces, creating that new sort of region there. These two still have a relationship because you have this central space that connects them. And here's another example of it with a radial sort of alignment. You've got the single space in here that is created by the collision of all four of these that are defining it on the inside there. Okay. So these have just been some simple examples with basic boxes. Now to show off some of them in actual implementation. One of the best examples I have is the school building I designed here that we showed last year. We can see a whole bunch of the various aspects coming into play. One of the most immediate is the simple shape. It's originally just a giant hexagon. So is how I originally defined and designed this building, is that basic hexagon. And then I started breaking it down from there. You can see there's sort of a radial repetition at each one of the points here that provides the connection between the outside loop of the hexagon and the inside loop. And then as we start to sort of blow these spaces apart, you can start to see some of the other relationships. It's set on a grid, a very regular grid pattern. Let me change my layers here. So there's the structural grid of the building. It's this repetitious bay. It's also called a datum. in which you can see that you have this repeated form that goes throughout the entire composition that unites it. So even when you have these spaces of different forms and shapes, having that repeated datum is what sort of brings all of those elements together. It unifies them in having the similar visual language. And then again, you see all this repetition here that sort of unites and defines the building as being, you know, a continuous space, and then broken down with other spaces inside it. You see here that basically we got the hall here, and then each one of these classrooms is defined by these bays. So in dividing this space up from the larger, and then you keep getting down and down and down to the little details, and then those details are carried throughout the entire design. You have that sort of overarching design idea that combines everything to keep it unified and all together. Let's see here. Yeah, there's a definite rhythm and repetition that, as I've said, unifies that space and makes it readable and understandable as a complete element. So I know I'm going over a lot in a real quick period of time, but hopefully this is enough to just provide you guys with this real simple foundation for thinking about kind of the most basic principles of architectural design and being able to either apply those to your own projects, whether you are an artist creating it yourself, or if you're giving direction to an artist to the kind of space that you want to create, or even if you're just a fan, you want to, you know, better appreciate the environments that your games are set in.
Yeah, I mean, as a photographer, when we frame up scenes and stuff, we look for very similar things. This is actually like the background to that. We look for lines, we look for things that draw interest, we look for putting things off center so that your eyes are drawn to it. And I'm seeing like the skeletons of that in this.
Right. Yeah, actually, if I go and open up this one, so here's a good example of a shrine that is, you know, a lot of shrines are essentially based on a very similar idea. You have this strong central axis right up the middle, because that's drawing all the visitors that are inside the space to go and visit it. And then you have the various repeated forms that are repeated across the buildings here. You're using the same kind of details that bring this whole structure together as a unified element here. So you can see sort of the repeated elements and stuff, which really makes it feel as though this space is, you know, could be a real space in the world. You have all the various pieces kind of working together using all the various principles I've described before.
Yeah, people are commenting. It's like, this is so much to take in that it's going to take a while for us to digest it.
Right. Yeah, that's, as I said, my intention is to just give you this basic framework. And like I said at the beginning, the text that I'm using is a real strong foundational text, and it is available to read for free on archive.org. That's Architecture, Form, Space, and Order by Francis Ching. So that's a really good resource. And he's done a lot of graphic design and just illustration books in general. He's a really strong figure in the field of just simple illustration.
All right. If you have any questions, we've got a couple of minutes. And then, all right, who's next? I got to check my own schedule. Oh, Sasquatchy's next. All right. So I'm going ahead.
If you could read off any of the questions. I don't have the Discord up because this is taking up my whole screen.
Yeah. Let's see here. Bingo sheet. Someone's asking for your types of reference material. We'll type that in later.
Yeah, I can dump a bunch of references. The one that I've already mentioned is one of the best ones for introduction, and anything after that, you're starting to get into real intense architecture school stuff.
Huh. So someone asked the question that I don't know how to frame, so I'm waiting for the clarification. All right, for now, I'm going to pass it over to Squatchy so she can get her stuff set up. And then
thank you, everyone, for listening.
Yes. All right. Okay, we'll just catch up in chat. what software was this? I think you were using SketchUp, right?
Correct. That was SketchUp for that particular one. But again, these are foundational principles. So any 3D program, 2D, you know, just piece of paper and a pencil, it's all the same foundation for building this design language that you can use to convey your ideas.
Yep. All right. What is this? What else is there? Cool. All right, we're gonna have to move on, though I'm still processing half of this. So, all right. That's awesome. Okay.